Hi, today I'm going to solve question 2 from May-June 2023 from the paper 1-1 of Cambridge AS Level Physics code 9702. Why am I solving this exercise? Because it's a very uncommon exercise and in my opinion a bit unfair. And you don't see it a lot in the past papers, so it's good to at least know how to approach it. Why do I say it's unfair? Because you have to remember a piece of information from the book that doesn't come up a lot. It does in some exercises as data given in the exam, but not normally. They don't request you to know this data. So the question is, what is the best estimate of the number of atoms in a piece of metal of volume 50 centimeters cubed? And you don't have any other piece of information. So the first time you approach this exercise, you think, well, we have to do it as you do it in chemistry with Avogadro's number, moles, etc. But this is physics and it doesn't really come in the syllabus. What does come in the syllabus and in some exercises, as data, is an approximation of the diameter of an atom. In the book it comes that it's more or less 2.3 times 10 to the power of minus 10 meters. We can use this number, or we can even approximate it to 2 or to even 10 to the power of minus 10 meters. As they are looking for an estimate, we just want to know more or less what the result would be. And as you see, the answers vary a lot in the power of the tens. So that's 15, 25, 29, and 31. So we just need an approximation. So we can use 2.3 times 10 to the power of minus 10, or we can use directly 10 to the power of minus 10. It won't change much the answer. The next thing we're going to do is we're going to consider the atom a sphere. We know it's not really like that, but again, it's an estimate. So the volume of a sphere is 4/3 pi r to the power of 3. R is the diameter divided by 2, so that we're going to do 10 to the power of minus 10 divided by 2, and that's to the power of 3. Okay? So we now have the volume of the complete piece of metal and the volume of one atom. So if we divide one into the other, we will get the number of atoms. So if we do, first of all, what is the total volume? Well, the total volume, it is given in centimeters cubed. 50 centimeters would be 0.5 meters, but it's cubed. We have to divide it by 100 to the power of 3. So that's 50 divided by 100, and it's cubed to the power of 3. So that's the total volume. And again, if we divide the total volume divided by the volume of one atom, we should get the number of atoms, which is what they want. And if we do that, it's 50 divided by 100 to the power of 3 divided by 4/3 pi. So that would be 50 times 3 times 8, which is 2 to the power of 3, divided by, I'm doing the inverse of the second one, 100. And that's, if we do the inverse, that's times 4 here, times pi. And 10 to the power of minus 10 cubed is 10 to the power of minus 30. So if we do this in the calculator, we get number of atoms is more or less 9.5 times 10 to the power of 25. Okay, so according to this is more or less 10 to the power 9.5 to 10 to the power of 25. So this is the correct estimate. If we had used 2.3 times 10 to the power of minus 10, we would have obtained something like 1.2 times 10 to the power of 25. So again, the important is the tenths part. And that would be, in both cases, we get a B. And that's the answer in the marking scheme. I think this is the best way to estimate this, and the easiest one. So again, the key point of information to remember is the diameter of an atom, which is this or this. And as I said, it comes in the book. It comes in several exercises and past papers. So it's something that they might require for you to know. And if you get such an exercise in the exam, well, this is how you do it.